to use Stokes' theorem, we know this line integral is just a double integral right there. But then when we calculate the curl of f, we see that's equal to the 0 vector, right? So then obviously this entire thing is just 0. But then why would they ask such a trivial question? So then the actual implication of this is that you see that this is kind of why path independence makes sense. So this is actually what the region looks like. If you can see that diagram right there, it's so the question says the plane x plus y plus z equals 1, right? The light blue part is the plane. The gray part is the base plane, and then the first octave means x and y and z, they all have to be positive. So then it's that little triangle right there. That's the region, right? And then since curl of f equals 0 and the region is simply connected, that means the line integral is path independent according to theorem 3 in textbook. So then when that's path independent, we can apply this the fundamental theorem. And then since if you integrate around a closed curve, that involves the starting point and the end point being the same. So then f of b minus f of a is essentially minusing like a 2, like f of a minus f of a. So then obviously that's 0. Okay, so that was the first part, which is pretty easy. And then this is the second part. So now we do the reverse of Stokes' theorem, so converting a double integral to a line integral. So then here, the boundary of that's the cone. So the boundary curve is this little part, this brownish part. This is the boundary curve. And then according to that's what z is for. And then according to the Stokes theorem, the positive sense of that curve should be anti-clockwise, because if we use the right-hand screw rule, we know that your thumb points to the normal vector direction, and the rest of your fingers are supposed to point to the positive sense of the curve. So then that's why it's anti-clockwise. And then so we just parametrize it and then everything. And then you just do this. This is all easy, and then you get that answer. So yeah, I'm done. Thank you.